I will begin by introducing our project. Workforce attendance is a critical element in human resource management, especially in the healthcare sector, where employees present directly affect daily clinic operations and service quality. Attendance records are not only used to ensure sufficient staffing, but they also provide valuable data to analyze employee discipline and working patterns. At U.n.i Klinik Metrocity, an electronic attendance system is used to record employee clock-in and clock-out activities. Based on interviews with the human resources departments, the overall attendance behavior of employees is considered good and clinic operations run smoothly without major discipline issue. However, when we examine the attendance data in detail, we identified several minor irregularities. These include missing clock-out records, attendance adjustment due to official training or maternity leave, and system delays during attendance recording. Although these issues do not reflect poor employees' behavior, they introduce inconsistency that may affect the accuracy of attendance performance evaluations. Another key issue is that the current attendance system mainly functions as a record-keeping tool and lacks analytical capabilities to evaluate performance, identify patterns, or support objective HR decision-making. So therefore, there is a need for a more systematic and data-driven approach to analyze attendance performance. Based on this, the objective of our study are to compare expected and actual working hours, to clean and process attendance data to resolve anomalies, to calculate daily attendance performance indicators, to apply machine learning techniques using WEKA, to identify important patterns and features, and to visualize attendance trends to support effective human resources decision making.
Next, I will explain the next slide. For this study, we use real employee attendance data from U.n.i Klinik Metrocity, covering the period from August to October 2025. The dataset consists of 235 attendance records with 7 case attributes, including actual working hours, lateness, early leave, overtime, and the Daily Performance Index, or DPI, which is used to classify attendance performance. For facial selection, we use the Select Attribute tabs in WEKA with the ranker search method. Two evaluation techniques were applied, namely Infogain Attribute Eval and Correlation Attribute Eval. Based on the Infogain result, DPI recorded the highest information gain value, making it the most influential attribute in classifying attendance performance. This is followed by the actual total working hours and total overtime hours, which show moderate influence. On the other hand, expected total working hours did not contribute meaningful information, indicating the scheduled hours alone do not differentiate performance. Similarly, the Correlation Attribute Eval results show that DPI has the strongest relationship with performance class, followed by early leave minutes and minute-lets. This indicates that attendance behaviors such as punctuality and early departure has a greater impact on performance compared to the total numbers of working hours. Overall, the feature selections result confirm that performance-based and behavioral indicators are more important than scheduled working expectation when evaluating employee attendance.
Next, I will explain the machine learning models and the decision tree analysis. We evaluated 3 machine learning models using the WEKA Classify tab, which are Filtered Classifier, Logistic Regression, and Bayes-Net. These models were used to classify employee attendance performance based on the selected attributes. The results shows that all 3 models achieve high accuracy, indicating that the attendance data is well structured and suitable for machine learning analysis. Among them, Filtered Classifier performed the best, producing the most stable and accurate classification results. Logistic Regression also showed strong performance, while Bayes-Net provided competitive results by modeling probabilistic relationships among attributes. To further support the classification results, we applied a decision tree analysis using the J48 algorithm. The decision tree shows that the Daily Performance Index, or DPI, appears as the root node, confirming that it is the most important factor in determining attendance performance. The decision tree produced simple and easy to understand rules. In general, higher DPI values lead to higher performance categories, while lower DPI values result in purer performance classifications. This makes the model transparent and explainable. Overall, the decision tree provides a clear and practical model that can be easily interpreted and used by the Human Resources Department for real attendance performance evaluation and decision making.
Based on the trend plots with DPI as the dependent variable, we observe clear patterns between attendance, behavior, and performance. For the actual total hours versus DPI plot, employees who consistently work between 8 to 10 hours are mostly classified as excellent, with DPI values above 95. In contrast, employees with lower working hours tend to show poor performance with lower DPI values. For minute late versus DPI plot, employees who are late by 0 to 1 minute mostly maintain excellent performance. However, as lateness increases, especially between 4 to 8 minutes, there's a clear decline in DPI and performance level. This highlights the importance of punctuality. Similarly, the early leave minutes versus DPI plot shows that employees who leave early for less than 10 minutes usually maintain high DPI values, while those who leave early for longer durations, especially more than 40 minutes, consistently show poor performance. For the total overtime hours versus DPI plot, moderate overtime of the 0 to 2 hours is associated with good and excellent performance. However, excessive overtime does not consistently improve DPI, suggesting diminishing returns.
Based on the findings from our analysis, we propose several recommendations to improve attendance performance monitoring at U.n.i Klinik Metrocity. First, we recommend adopting the Daily Performance Index or DPI as a standard metric for daily attendance evaluations. Our results show that DPI is the most influential indicator in classifying attendance performance, and it reflects actual employee behavior rather than just scheduled working hours. And by using DPI consistently, HR can evaluate attendance performance in a more objective and data-driven manner. Secondly, early interventions should be implemented for employees who frequently arrive late or leave early. Our trend analysis indicates that lateness and early departure have a stronger negative impact on performance compared to overtime. By monitoring recurring patterns of lateness and early leave, HR can address potential issues early before they affect overall attendance performance. Third, overtime usage should be managed carefully. The findings show that moderate overtime can support good performance, but excessive overtime does not necessarily improve DPI and may indicate workload imbalance or inefficiency. Therefore, HR should ensure a balanced workload and avoid over-reliance on overtime as a performance indicator. Based on this, the objective of our study are to compare expected and actual working hours, to clean and process attendance data to resolve anomalies, to calculate daily attendance performance indicators, to apply machine learning techniques using WCA to identify important patterns and features, and to visualize attendance trends to support effective human resources decision making.
Overall, the trend analysis shows that the DPI is strongly influenced by attendance discipline, punctuality, and early leave affect performance more negatively than overtime, indicating that discipline-related behavior is more important than working longer hours. In conclusion, the Daily Performance Index is a reliable indicator for evaluating attendance quality and can support objective and data-driven human resource decision-making at U.n.i Klinik Metrocity.